Hi guys, how we doing? Welcome back to another video. So I'm teaching myself microcontroller programming. I'm using this bit of kit called EBlocks, and I'm going through this curriculum called Introduction to Microcontroller Programming. Pretty cool bit of kit. I must say I've just had some pretty good conversations with. So obviously I work for this company Matrix now. I just started working. I've been there 2 months now, and I've had some good conversations with the guys that built this hardware. And essentially this curriculum is super old. It's like 15 years old and it hasn't been updated properly, and so that's why it's very poor. So I'm going through it. It's 101 pages and I am on page like 84, I think. So I was doing interrupts. So I did external interrupts in the last video, and then now we're using timer interrupts. So I mean, I'm just trying to get through this. I've got 15 pages left of it. I can't wait to be done, and I genuinely cannot wait to redo this. This is a very poor curriculum, and I think if I redo it, I'll learn loads, and you know, hopefully some students will be able to as well. So timer interrupts. I'm guessing what this is similar to a PLC. On PLCs, you have like a safety program, and that runs at an interrupt, or you have a cyclic interrupt that will run every 15 milliseconds, and you'd use that to control your motor control code. So I'm guessing this is a similar thing. So let's give it a go. The other type of interrupt function in Flowcode is a timer interrupt. These allow you to perform software tasks at precisely predetermined time intervals. A really useful feature when developing time-critical applications and clocks. Cool. So, objectives. Create and use a timer interrupt. Use a prescaler to create accurate time intervals. Trigger the timer using a crystal or an external event. Okay. So, I believe this thingy here is the crystal oscillator, and it's right next to the main chip, the PIC. You get a PIC, and then right next to it is crystal oscillator, so it's an external one. Cool. Finally, some information. You know, this is what this curriculum is needed. Just give us some more information before just giving me a task. You know, it did the same a little bit with the external interrupts. Yeah, it didn't give me any information there. Just okay, it gave me this little blurb here. But then now look, this is some chunky bit of information here. So I want to read information. I want information. I want relevant information. So I'm happy to see this. So the 16F18877 has several timers, but we look at only two. Timer 0 and timer TMR 0 and TMR 1. Okay. And then look at that, the bracket. This is wrong, right? It's got timer 0 and then timer 0 again. I don't know what's happening there. Alright, so TMR 0 can be... Okay, yeah, so that's... No, yeah, I don't know. TMR 0 can be triggered by the crystal or by transition to the TOC I pin. Okay, which is mappable on ports B and C. Okay. I'm not sure I understand that. It can either be triggered by the crystal or it can be triggered by essentially port B and C. Okay. The internal clock has a frequency of crystal clock frequency divided by 4. The internal clock. What's the internal clock? I guess of the PIC microcontroller. Okay. Has a frequency of crystal clock frequency. So it said 32 megahertz, but is that just assuming I have a PIC? Okay, yeah, the PIC 16F187. Yeah, okay. So 32 megahertz divided by 4. So the internal clock on this thing is 8 megahertz. That's what I'm understanding, I think. So the TMR prescale can be set from 1 to 2 to so 1 to 2 ratio to a 1 to 32,768. That's just the largest integer ratio. So for this exercise, set it to 1 to 2 so that every 8 megahertz divide by 65536 divide by 2 clock pulses cause what? Okay, cause the TMR 0 to increase by 1. I have no idea what that means. The prescale can be set from a ratio of 1 to 2 to 1 to 32,000. Set it to 1 to 2 such that every 8 megahertz 2 clock pulses, I don't know, cause, yeah, okay. This happens at a frequency of, okay, I assume there's a reason why we're dividing by 65,000 there. So let's just ask the old chat GPT. Why do we divide by 65,000 in this screenshot about internal clock frequency of a microcontroller? What it says. And I need to ask about the divide by 2 as well. It appears that 65,536 is used as part of the equation to determine the frequency of a signal generated by a microcontroller. Here's why. 65,000 is 2 to the power of 16. Okay, well, they could have said that. This comes from the fact that many microcontrollers use 16-bit timers. So, okay, going back here. So we have a 16-bit timer. Again, this could have been explained in here. A 16-bit timer can count from 0 to 65535, so its total range is 60. Okay, the timer over counter, or the timer counter, runs based on the internal clock of the microcontroller. Dividing by that, if a 16-bit timer is being used, it counts up clock cycles before it overflows. So to calculate the resulting frequency of an output signal, like a PWM signal or timer interrupt, you divide the clock frequency by this number to account for the full cycle of the timer. Okay, why divide by 2? The division by 2 likely comes from how the signal is toggled or the timer is set to trigger an event. I think that divide by 2 is this prescaler of 1 to 2. I think that's what that is, but again, don't know. Let's just say to ChatGPT, does this help? Show it and then just see what it comes up with. I mean, this is so insane that it just does this for me. So yes, this excerpt does clarify things further. Internal clock. The internal clock has a frequency of 32 megahertz, which is divided by 4, giving 8 megahertz as the clock driving timers. Prescaler. The prescaler for TMR0 is set to 1 to 2, meaning that every 2 clock pulses from the 8 megahertz clock, TMR0 increments by 1. This halves the effective clock frequency for the timer, making it 4 megahertz. Okay, the 16-bit timer counts up to 65536, 2 to the power of 16. As previously mentioned, the overflow occurs when the timer reaches this value, which is when the next clock pulse can cause the timer to reset and potentially trigger an interrupt. Okay. Final calculation. Given the 8 MHz clock, the prescale of 1 to 2, and the 60-bit counter that can count up, the overflow frequency is calculated as 8 MHz divided by that is equal to 61 Hz. This means a timer will overflow approximately 61 times per second, generating an interrupt or triggering some action at that rate. Oh, that's cool. Okay, yeah, so again, I mean, this is just ChatGPT, it just rules the world, doesn't it? I mean, it's just far superior to anything a human can explain. All right, instead of using that crystal, this timer can also be clocked by an external event, as when measuring motor speed, etc. TMR1 can be triggered by the crystal oscillator or by transition on a T1 CKI in all pins on port A and port C. I find this confusing about E-blocks. Like, why is it that, where's the other one? Ports B and C, and then over here it's port A, all pins on port A and C, and then up here it's, which is map on port B and C, yeah, or B or C, I don't know. All right, so let's just give, it's just going to give me a task, and we're just going to have to see if I can do it, but yeah, I doubt it. I mean, what I'm not going to do is, I think I'm not going to bother with 4, 3, and 4, because these just become too long. I'll do this one in this video, or I'll attempt it, and then I'll attempt that one in the next video. So, write a program to produce a precise seconds timer that displays the result on the LCD and starts when the microcontroller is reset. Use a 1-second delay. Don't use a timer interrupt. What? Okay, and it says do that, and then rewrite the program using a timer interrupt. Okay. So pretty simple code to begin with. We don't want to use a timer interrupt or anything, so let's just clear. We'll do timer count, sure. Increment that every 1 second, sure. Delete the interrupt, delete this if statement, and delete this macro. We'll start the screen. Oh yeah, we need to write to the screen. So I've got a function here. Oh, built-in function. Nope. Use a macro. I've got a function here called write to screen that I did in the last video, and that just clears the screen, sets my cursor to 0, prints the string result, which I'll change to time elapsed, and then set my cursor to the next row, and then print that timer count. So write to screen. And do I need to? Yeah, I think that'll be okay. I'm gonna clear it again. I should put a delay. We'll put a delay there. All right, cool. Don't need this flag. Let's give that a download. This should be nice and simple. I've just saved over my last project. Damn. Why did I do that? So this is just counting in seconds without using a timer. And then it wants me to rewrite it using a timer. I should have started with a new product. All right, that's been sent now. So we've got time elapsed, 6 seconds, 7 seconds, 8 seconds, 9 seconds. So what did it say? It wanted me to use a timer. So let's do, did I do clock? Stopwatch. Yeah. Reset that, and then we'll press go at the same time. All right, cool. So I guess what we're going to see is that even though we're using a delay, it's not going to be accurate. So we've got time elapsed 7 seconds, 8 seconds. I mean, it's pretty accurate. I don't see what the problem is there, do you? Time elapsed. What's the problem? That's working fine. I mean, can I just start pressing other stuff? Is it gonna mess it up? No? What if I turn the screen on and off? That's perfect. So what's the problem here? I guess. Oh yeah. Obviously, I'm not doing anything in my code. So, for example, if I wanted to do this, but in my code, let's say I had, I don't know. We'll put some calculation, and we'll just say, I don't know, Ahmed is equal to, you plus me. I don't even know. Yeah, I don't know. I can't even do. Okay, 99 plus 65,000. All right, I'm just doing nonsense. Doesn't make sense. Anyways, hopefully you get what I'm trying to do here. So that doesn't even make sense. So if I then put, I don't know, a delay here. Okay, what I should just, okay, this is dumb. Let's just keep it much more simple. So make a decision and then just check if port A, how do I get to ports? IO. If there's anything pressed on port A, then do this calculation, right? And delay by 500 milliseconds. So that now is going to start to throw the microcontroller off, and then because I've got this 500 millisecond delay, that will then mess up the the timing. So I guess by using an interrupt, that won't happen. Even pressing and doing other stuff in the code, it won't mess up. So let's just give this another go. I'm gonna press time elapsed. We're gonna start. Cool. So 1, 2, 3, 4. I can't actually look at both at the same time, but they seem to be okay. So now if I press anything on port A, it should start messing up. There should be a delay, but is there? Can you look at both of them at the same time? So 24, 25, 26, 27, 28. I mean, okay, yeah. So they've messed up now. So yeah, this is where obviously now you need an interrupt. And so the interrupt is going to ignore all my button presses and just keep up with the timing. If I just press this load. Look at that, yeah, we're at 50 and 55 now. So yeah, cool, all right. So that proves that. So that's what I wanted. So now what we're saying is rewrite the program using a timer interrupt. Interesting. Okay. How do we do that, people? Call an interrupt here at the beginning. I don't know, man. I mean, what does it just say? It just, okay. So I've selected interrupt on timer, and then we've got timer 1, timer 0. Oh, sorry, you guys can't see. We've got timer 1 and timer 0. I'm assuming we want to go on timer 0. But what's all these other timers? Okay. So timer 0. And then properties. And then we want to do internal clock, prescaler rate. Did it say it was 1 to 2? Yep. And Toki pin selection. I can't remember what that does. What does this Toki pin selection do? TMR1 can be triggered by the crystal oscillator by a transition on tick I pin, all pins on A and C. Where's the Toki one? Oh, there. TMR0 can be triggered by the crystal or by transition on Toki pin, which is mappable in ports B and C. So I don't want to do that. I don't want to do that though. So can't I just deselect that? I don't know why I can't deselect that, because if I select one of the B ports on here, these are always turning on because of the screen. So I'll leave it as A0 and I just won't press A0. So now press that. So on timer interrupt, it will call, and then let's select the reaction time. And then we'll change the code here. So we will get it to do this stuff in this reaction time code. So what we're doing there is we're gonna add an interrupt, which is hopefully every whatever we selected, 61 hertz, 61 times a second. It should just keep calling that. Oh wait, is that right? That's not right, because that's gonna increment it 61 times a second. Is that why it wanted me to divide it by 65,000? What did ChatGPT say again? The prescaler is set to 1 to 2, meaning that every 2 clock pulses from the 8 megahertz, TMR0 increments by 1. I'm not sure. I don't know what's gonna happen here. I don't fully understand what I've read. So we're calling an interrupt. This could be much easier, and I don't know why it isn't. So clock speed is 32 megahertz. Interrupt frequency is 61 hertz. I don't want that. I want 1 hertz. So, 0.95 hertz. 1.9 hertz. So I got 0.954 hertz there. What's this? So it's going. Oh, 30 hertz, 20 hertz, 12 hertz, 6 hertz. This is a bit random. Can't I just type in what hertz I want and you sort it out for me? This 3.8 hertz. I have no idea what I'm doing. There needs to be far more explanation to this. This is insane. What I will do is, because this video is taking forever, and you know, if you're still watching this, you know, props to you, man. Bloody hell, this is painful for me. So I'm actually gonna go a step further and go on the bloody wiki, yeah, and I'm actually gonna try and figure this thing out. So if I do Flowcode wiki, it's just this. Yeah, I want interrupts. No, I want a timer interrupt. I've searched timer interrupt. It's telling me I can create a page for it. Flowchart fundamentals, external interrupt, timer interrupt. Okay, so let's go there, and there's also an interrupts page as well. There's interrupts. Most devices have built-in interrupts, blah, blah, blah. Timer interrupts. Timer interrupts are useful for monitoring the passage of time. Whether you want something to happen on a regular tick or simply want to measure how long something has taken, a timer interrupt can prove to be a very handy tool. Example program. Int single pin interrupts. The int type interrupts allows you to wait, what? Software PWM. Example program showing how to generate software PWM to drive multiple LEDs. What? Tell me how to do a 1 second timer. Okay, so let's ask the old chat GPT, because we'll just have, is there anything else? Flowchart fundamentals, timer interrupt. I can't select that. Oh dear. It's just painful, this stuff, man. It genuinely is painful. All right. Chat GPT. So I always, this course makes me feel like an idiot, and it's insane, really. I mean, I'm 32 years old, and I just think, literally, this was designed for someone half my age and with no experience. So I mean, yeah, props to any 16-year-old that can understand this. All right, what settings do I use to get a 1 second interrupt? Come on, ChatGPT, don't let me down. Alright, you can keep the clock source as the internal clock at 8 MHz derived from the 32 MHz base clock. Start by increasing the prescaler value. Since you currently have it set at 1 to 2 and are getting 61 Hz frequency, we need a slower rate to achieve 1 Hz. Use a prescaler of 1 to 256. Alright, ChatGPT, yes boss, 1 to 256. That should equal 31 Hz. It doesn't. 31,000 Hz. What? Timer overflow. Timer overflow will overflow when it reaches a maximum of, with a counter frequency of 31,000. 2 seconds to overflow. To get a 1 second interrupt, you should preload the timer with a value so it overflows after exactly 1 second. Calculate the preload value, blah blah blah. So you should load the timer with 34,286 at the start to ensure it overflows after 1 second. How do I do that? Well, set the timer initial value to 34,286. So let me just show you. Let's just make sure ChatGPT knows what it's talking about. So this is the settings with 1 to 256. Just confirm it's happy with that, because that to me says interrupt frequency of 0.4. You're getting an interrupt frequency of 0.4, which is approximately 1 interrupt every 2.1 seconds. This matches the calculation from earlier. Okay, so they did. So ChatGPT knows what it's talking about. So preload example in C or assembly for a pick. Preload the timer with 34,286 to get a 1 second overflow. Now, how do I do that in Flowcode? How do I do that in Flowcode? I was saying to one of the main programmers at Matrix, really clever guy. I said to him today, I need to learn how to write in C in this thing, because I like flowcharts, but bloody hell, just look at C. Like, that's just simple. I just love C. All right. What? Insert a calculation block to set the high and low bytes of TMR0. Use Okay, so we'll try that, but there should be something easier than that. Create a new macro. Okay, and edit macro. Alright, let's try a calculation block. I just have no idea what I'm doing. He's gonna be happy with that? Not happy with that. He's not happy with, okay, that's a calculation block. Set a calculation block to set the high and low bytes for TMR 0. Open your Flowcode project, add a calculation block, preload timer. You use a calculation block before starting the timer. Inside the calculation block, you assign initial value directly to the TMR register. Let me try C code. Alright, that seems to have accepted it. Let's just try it. Please work. What I should do is I should increase the delay, this 500 millisecond delay, to make the delay from pressing port A more obvious. Oh man, bloody painful. We'll get there. I like this hardware. I'm pretty confident that we'll get there. So we'll go. Oh, screen is not doing anything. The screen's not doing anything because no, the screen should be doing something. That timer should be active now. That interrupt should be active now. So it's not doing anything. It's interesting. So let's just delete this C code that we just added and try again. I'll make this delay larger. Like I said, make it obvious. And go again. I didn't expect that C code to work. I'm not convinced about Flowcode's ability with C code yet. Either Flowcode is that good that C code isn't needed, or no one at my workplace likes C and hence just doesn't use it. But I find it hard to believe that you're programming microcontrollers and you're not using C and you're not using C++. I find that hard to believe. So, all right, that still hasn't worked. Nothing's on my screen. Which means the interrupt is not running, because my code is literally start the screen and then that interrupt should be running now. So why are you not running? Timer 0, full reaction time. What happens in reaction time? In reaction time, we increment the timer and we write to the screen. Oh, what do we write to the screen? Yes. Oh yeah, no, that's correct. We write to the screen. Time elapsed, and we print the timer count, and the timer count goes up by 1. Oh, we don't need a delay, I guess. And I guess, okay, I could have, so yeah, I'll increment the time count, and then on the screen here, I'll just write to the screen there, and then maybe a little 20 millisecond delay there, just, I don't know, just in case. When it comes to writing to the screen, I'm not fully confident that you could just write to the screen without a delay. I feel like it sends the command and then clears it. So little slight delay there. All right. So we download and have a look. Let's see if anything happens this time. So now in my timer interrupt, all I'm doing is incrementing. Oh, we're writing to the screen. So these LEDs are going nuts, which means it's writing to the screen way too much. So that's probably causing me an issue. So let's just fix that. So we currently got right to the screen with 20 millisecond delay. Let's go with a 250 millisecond delay. And then just try that again. Yeah, I mean, I can see those PWM wise. Look, there you go. They're just spasming like crazy. So that means that the controller's like right into the screen a lot. All right. So I have some faith that this might work actually. Yeah, maybe not. We'll see. Yeah, man. All right, so. Oh my gosh. Yes. Yes. All right, cool. So, moment of truth then. Let's get our ready, steady, go. All right, so. Oh, no, we're way off already. Is that from my delay on writing to the screen? Or is that, oh yeah, okay. This is every 2 seconds, isn't it? I think. Yeah, okay. So the code's working now, but we don't have ChatGPT's scaling stuff going on. So let's try that. We will add in this C code and see. So we basically need to set an initial value for the timer interrupt, I think. But isn't that? Yeah, I don't fully understand how this is going to work, to be honest with you. If it does, I'll be happy though. I suspect it's not going to do anything. All right, so that C code's been sent. It's currently just writing 0. So, do I have to like use this C code outside of my while loop? Because if every single program iteration, it's setting that to overflow, I have no idea what I'm doing. I mean, when I get to this point in the video, and this has happened, at least 10 times now, I just quit because I've learned the concept, but not fully, and I'm not going to learn it fully on this video by rambling to you. I'm going to have to speak to the clever guys that I work with and, crawl through the wiki and argue with ChatGPT. So that is incrementing now, but we don't know at what rate. I'm not the best when it comes to counting seconds. So let's just go for a reset. 3, 2, 1. Oh, wait. 3, 2, 1. All right, cool. Yeah, so it's still way too slow. Half the speed. So that's still 2 seconds, which is kind of... So this C code's not doing anything, which I didn't think it would, to be honest with you. So we have this timer, 0. I'm going to spend a total of another 30 seconds on this, and then I bid you guys farewell. We have an interrupt frequency of 0.4, and that just halves it. So if I go for a 128, and then I get a 1, I get a 0.954. I don't know why that can't be 1 hertz. I'm not clever enough to understand why that can't be 1 hertz, but to me, I expect that when I have a timer interrupt, I just like click the properties or something, and you just give me a selection here of what frequency do you want the interrupt to occur at, and I just go, milliseconds. Just make it simple. I hear. And I guess maybe this level of detail is good for clever people, or advanced. But introduction to microcontrollers, man. Introduction to microcontrollers. That word is missed on this on this course. Introduction. Right, we need to bang that one home. Introduction to microcontrollers. Anyways, cool. So this should work somewhat very close to 1 hertz. It's 0.95 hertz. So I suspect me and you should be able to tell no difference. I hope. So let's just reset and start. So we should be bang on now. 4 seconds, 5 seconds, 6 seconds, 7 seconds, 8. All right. So I have a 2-second delay when you press any of these buttons, apart from A0. I don't know what happens when you press A0. If you press any of these buttons, it should go into this code here, and it should do x is equal to 99 plus 65,000, and then wait 2 seconds. That's what it should do. Then the timer interrupt should interrupt it twice that second and still continue updating that value. However, what I expect to happen is my write to screen code exists here in the main while loop of the code and not inside the interrupt. So therefore, I think what we're going to get is the screen is going to delay and stop for 2 seconds, and then it will increment with the correct value, which will still continuously be in line with this. So that's what I think is going to happen. I'm going to press the button now. Let's see. Okay, look, screen's frozen at 75. Okay, we can't really tell because now we're at 81 and 1 minute 25, and who can do that calculation? 60 seconds is too high for us, right? So go again. All right. So now if I start pressing things, look, it's stuck on 4 and it should just increment, boom, and it should stay. I love it. I love it. So it's a bit crap that the screen freezes, but that's okay. Like, I mean, if I was using my computer and it was lagging and doing something and then I started clicking, usually it takes my click from my mouse as an interrupt, and then stuff gets stopped and and then it kind of freezes and then does something. That's usually what your computer does when it's lagging and you're dealing with interrupts. So I don't mind that. 35 seconds, it's frozen right now. It's like, oh my gosh, I'm frozen. And then boom, straight to 40. No. Oh, we kind of lost it a bit there. We've lagged a bit there. I don't know if that's that 0.95 and not being 1 hertz, but we've lost it a bit there. So we're not fully in line. But I give up there because this is way too long. I apologize. I mean, I had fun actually. I must say this is. I love this. This hardware is fantastic. This PDF is atrocious. The hardware, beautiful. If we can get the PDF up to the hardware state, I'll be very happy. Cool. Thanks for watching, guys. I'm not sure I am going to do this second one. I kind of just think there's no point. Write a program to create a basketball timer that starts when switch 0 is pressed and displays the time elapsed on the LCD. Yeah, you know what? Yeah, I just want to be done with this, so I'm not going to do that as well. We'll skip that, and in the next video we will do additional challenges. Flowcode has a sophisticated simulation engine. All right, go on. Yeah, we'll try to use the Flowcode simulation engine. I really just want to be done with this course so I can start working on it myself. So cool. Thanks for watching, guys. I'll see you in the next one. Take care. Bye bye.